You are welcome to chemistry class with an Christopher GK, your usual chemistry teacher. And in this particular video, we are going to consider a topic titled Empirical and Molecular Formulae. Empirical and molecular formula is the topic of today's class and to this particular video. And it's expected that by the end of this particular class, you must have learned how to compute the percentage composition of a compound. Number two, you should be able to learn how to determine the empirical formula of a compound. Then number three is you should be able to learn, you should have known how to determine the molecular formula of a compound. So these three things you want to achieve by the end of this particular video class. So let's take them one after the other by starting first of all with what empirical and molecular formula is. Now, empirical and molecular formula, what are they? Now, this particular thing, empirical and molecular formula, have their basis from the relative molecular mass, molar mass, and percentage composition of a compound. This is where it anchors on. And the issue of relative molecular mass and molar mass. If the formula of a particular substance and the relative atomic masses of each of the elements are known, then it is now possible to determine the relative molecular mass of that substance. Now listen, relative molecular mass, what you just need is to know the formula of a compound. Once you know the formula of a compound and the relative atomic mass of each of the elements is being given to you, is being known, is being given, then getting the relative molecular mass is no longer the problem. You need the formula, you need the values of the relative atomic mass of those elements. But at the same time, the relative atomic masses are fixed. You might have known them in your periodic table, but even though that you don't know them, in most cases, it will be given to you. It will be given to you and you use them to calculate. Now, how do we do it? Relative molecular mass of a compound is the sum of the masses of all the atoms present in one mole of the compound. Now, when a particular substance or compound is being given to you, just sum all the masses, the elements present in that particular molecule, in that particular compound, sum the relative atomic mass of them, of the elements. When you sum it up, you have gotten relative molecular mass of that compound. That is it. So something like NaCl, which is sodium chloride, the relative molecular mass is sodium, which is Na, is 23, plus chlorine, which is 35.5. When you sum it together, you're going to have 58.5. 58.5, that is the relative molecular mass of such compound, which is sodium chloride. It's very simple, sum it up. When you have something like ethanol, which is C2H5OH, carbon is 12, hydrogen is 2, oxygen is 6. With the formula given to you, sum it up. Carbon is 2, is 2 there. That means 12 times 2, plus hydrogen, which is 1 times 5, plus oxygen, which is 1, which is 16 here, and is only 1 there, 16 plus hydrogen. Sum it up, and you're going to have 24 plus 5 plus 16 plus 1. You're going to have 46. That is the relative molecular mass of ethanol. Ethanol. Very, very simple. I hope you are following. Now, let's look at this. Molar mass. Is there anything different from molar mass? Anything different from molar mass and in relative molecular mass? They are almost the same thing. It's all about in gram. Relative molecular mass you just express it in gram. When you express it in gram, it's the same thing. Molar mass and relative molecular mass, they are the same thing. They are the same thing. Now, what it means is that in 12 grams of carbon, which is carbon 12, we have 6.6 times 10 raised to the power of 23 atoms. Sometimes you can also see 6.02 times 10 raised to the power of 23 atoms. The same, it doesn't mean anything. the variation, there is no problem with that. Now, this is what we call Avogadro's number, Avogadro's constant. This particular number is telling us that 1 mole of any compound, 1 mole of elements, 1 mole of carbon, 12 carbon, 1 mole of hydrogen, 1 mole of oxygen, 1 mole of sodium, 1 mole of chlorine, 1 mole of anything, 1 mole of even compound, of any compound contains the same number. If it is a compound, that means such number of molecules. If it's an element, such number of atoms is on it. So 1 mole of any substance is the amount of that substance which contains 6 times 10 raised to the power of 23 particles. Particles in the sense that it could be atom, it could be element, it could be ions. So any of them, but when we use a particle, it summarizes it just for any of them, it can serve that purpose. So 1 mole of ethanol has how many grams? 46 grams based on our calculation. And it contains how many molecules? 6 times 10 raised to the power of 23 molecules of ethanol. That is the meaning. The same number is what 1 mole of hydrogen contains, 1 mole of carbon contains, 1 mole of sodium contains, but that their own is atoms. That is a wonderful one. We call it Avogadro's number or Avogadro's constant. Okay, now let's look at the composition, percentage composition of a compound. Whenever you hear about percentage, is all about 100, all about 100. Now, to calculate the percentage composition of ethanol, whose molecular formula is C2H5OH, given that the relative molecular masses of carbon, hydrogen, and oxygen is 12, 1, and 16 respectively. Of course, first, what do we need to do? Percentage composition and how the percentage of this compound, how they are being composed in this particular compound. Percentage of carbon, percentage of hydrogen, percentage of oxygen in this particular compound. Now, first thing we need to do is calculate the molar mass of the compound altogether. And when you calculate it, of course, we did it before, what you're going to have is 46, which is 12 times 2, which is carbon, plus 1 times 5, which is hydrogen, plus 16, which is oxygen, plus 1, altogether 16 grams. Now you're going to divide each one based on their, you are going to determine it based each, carbon, hydrogen, oxygen. You are going to determine each. So then determine the masses of hydrogen, carbon, and oxygen present there. So mass of carbon is 12 times 2. It gives you 24. Mass of hydrogen present in that particular one is 6. How do we get 6? We know that H2, C2, H5, OH. That means H again after O gives you hydrogen, 6 hydrogen in that. 1 times 6 gives you 6 grams. Mass of oxygen is 1. 16 times 1, you have that. Molar mass of the compound entirely is 46. So percentage composition will now be divide each one by the total molecular mass times 100 over 1. Times 100 over 1. So percentage of carbon now is carbon, which is 24, and that compound will be 24 divided by 46 times 100 over 1, which is going to give you 52.17%. That is the percentage of carbon in this compound. Now, percentage of hydrogen will now be 6 divided by 46 times 100 over 1. It's going to give you 13.04%. That is the percentage of hydrogen in this particular compound. And the percentage of oxygen will now be 16 all over 46 times 100 over 1. You are going to have 13.04% also. All right, that is the percentage there. What are we trying to say? In calculation of chemical formula from percentage composition by mass, we can determine the simplest chemical formula of a compound, given its percentage composition. If we have been given percentage composition, we can calculate the chemical formula of that. If the formula of an hydrous disodium triazocarbonate 4 is not known, if its percentage composition by mass is known, then its chemical formula could be calculated. Generally, if you don't know the formula of a compound, but the percentage composition is given to you, you can get the compound, you can get the formula. That is what I want to talk about, how to get the chemical formula of a compound when percentage composition is given to you. All right, for example, let's take, for example, percentage composition of the compound was found to be sodium 43.40%, carbon 11.32%, and oxygen 45.28%. All right. This will mean, by this, it will mean that in every 100 grams of the compound, the masses of sodium, carbon, and oxygen were 43.40 grams, that is for sodium, 11.32 grams, that is for carbon, and 45.2 grams, 42 grams, that is of oxygen, respectively. That is what it means. Now, the amount in mole of sodium, carbon, and oxygen, what we will do now is divide each percentage by the relative atomic mass of that element. Here we are giving 43.40 as the percentage of sodium in the compound given to us. But sodium itself, the relative atomic mass of sodium is 23. So divide the percentage by 23. We are given the percentage of carbon here is 11.32. Divide it by 12. That is the relative atomic mass of carbon. Oxygen is given to us here as 45.28. Divide it by 16, which is the relative atomic mass of oxygen. If you divide so, generally, you are going to have them this way. Sodium, you are going to have, when you divide it, you are going to have 1.89. That is the amount in mole of that. The amount in mole of the carbon, it will now be 0.49. The amount in mole of oxygen is going to be 2.83. If you have gotten this, for next thing you are going to do is check all of them. Divide both, all of them, by the smallest number. When you check the smallest figure, smallest mole, there you are going to observe that carbon has 0.94, which is smaller than 1.89 of that of sodium. So when you multiply, when you divide through, you observe that, meaning 1.89 divided by 0.94, that is for sodium, you will divide the same with 0.94 will divide itself, 2.83 will divide by 0.94. So you use the smallest number of moles to divide all of them. And when you divide, you are going to have 2 for sodium. Carbon, you are going to have it will, because it will divide itself, the number of moles, it will give you 1. That of the carbon, that of the oxygen, I mean, is going to give you 3. Having gone that way, what it means that the ratio of the mole there is 2:1:3, meaning that carbon, sodium is 2 there, carbon is 1, oxygen is 3. If you do that, bring the formula. Sodium now, put 2 as subscript, carbon is 1, oxygen, put 3 as the subscript. That is the meaning. Then the simplest formula there is therefore this, and this is sodium carbonate, which is sodium triazote carbonate 4. We have gotten the formula with the percentage given to us. That is the meaning. Let's now look at this once again. Empirical formula now and molecular formula. What do they mean? Empirical formula is the chemical formula from percentage composition by mass, while the molecular formula of a compound is a whole number multiplied of its empirical formula given. Empirical formula is the simplest formula we can have. Then the molecular formula will now give us the whole detail we need to know of the full formula that we have calculated. Let's take some examples. Find the empirical formula of a compound which contains 80% carbon, and the 20% hydrogen by mass. These are two compounds. We don't know what the compound is, but the percentage composition is being given to us. The relative atomic masses of those elements we are given to us. Now, what we will do is this. Percentage of carbon is 80, percentage of hydrogen is 20, and you have to divide the percentage by the relative atomic mass of each element given to you. When you do so, carbon 80 divided by 12, you are going to have 6.6. That of the hydrogen, 20 divided by 1 is going to have 20. The next stage now is divide both that of the number of mole of, that means they divide both 6.6 and the 20 by the smallest. Two of them, which one is smaller? The one that is smaller is 6.6. Divide it by itself and also divide 20 by that. When you divide it, that means divided by the smaller number. 26.6 divided by itself and divide also 20. You're going to have 1:3. What it means now is that carbon is 1, hydrogen is 3. When you bring it together, you're going to have CH3. CH3, that is empirical formula, how to calculate the empirical formula of a compound. However, this has not given us the full details that we need as a compound. We can further to get to know the particular name of this compound when calculating molecular formula. But that is how to calculate the empirical formula of a compound. All right, let's take number 2. Question says, find the empirical formula of a compound which analysis yield the following as the reacting masses: carbon 2.0, hydrogen 0.34 gram, oxygen 2.67 gram. From your results or from the results, find the molar mass of the compound. This one, molar mass of the compound. If its relative molecular mass is 60, you are asked to find the relative molecular mass. Find the molecular mass of the compound. For molecular formula, sorry, but the truth is that you can't get molar mass without getting empirical formula. You can't get molecular formula without getting empirical formula. So if this kind of question is being given to you, find the empirical formula. After getting the empirical formula, equate it into 60, which is given to you. The relative molecular mass of the whole of them is 60. Then you now solve and get your final, the particular molecular formula that the analysis yielded this. All right, let's solve it. The solution is this, given to you, the grams we are given 20 for carbon, 0.34 was given to you for hydrogen, and 2.67 was given to you for hydrogen. When you divide them by the relative atomic mass of each of the elements that was given to you, you are going to have the number of mole as 0.17 for carbon, 0.34 for hydrogen, 0.17 for oxygen. Now check all of them. Which one is smaller? 0.17 appeared 2 times and is smaller than 0.34. You are going to use it to divide both all the sides. So when you divide it, you are going to have 1:2:1. 1:2:1. That is the subscript. It's telling you that the empirical formula of the compound is carbon is 1, hydrogen is 2, and oxygen is 1. That is the empirical formula. Had it been that you are told to just find the empirical formula, you have to stop here. But for the fact you are told to find molecular formula, you have to further it by equating this particular empirical formula to 60. So you close the bracket and put S. S means you are just a number. You are looking for the number that when you multiply it through, it will give you the molecular formula. You are told that relative molecular masses of all of them is 60, is given to you in that question. We got it. The relative molecular masses of all the elements put together is 60. So you equate this particular empirical formula to 60, and you further again your solving. But carbon here is 12, we know. Hydrogen is 1 times 2 there, plus oxygen. Add all of them together. When you add all of them together, we're going to get 30. 30x equal to 60. Open the bracket and make S the subject of formula. When you divide 60 divided by 30, you're going to get 2. That means that S is 2. What you now do is that bring that relative molecular formula, bring that empirical formula and put to where S is and use it to open the brackets. When you do so, you are going to have 2 times C is going to have C2, 2 times H2, you are going to have H4, 2 times oxygen, you are going to have oxygen 2 or O2. Or you're going to put it this way. If you didn't put it this way, you put the formula like this, CH3COOH, which is what? Ethanoic acid. However, you're not told to pronounce the compound, but that is the compound. Ethanoic acid is what had that analysis. So this formula that you derive now is the molecular formula. That is how to calculate the molecular formula. Thank you. And for further discussion and inquiry, do well to contact me through my phone line. By what? Getting me through my line +234 80 655 73229 +234 80 655 73229. Or you can send me an email through my email address at crystal116@gmail.com, at crystal116@gmail.com. And as you do so, remember to give us comments. Give us comments on this particular video after watching it, and I will be delighted to hear from you. Thank you for listening and being part of this particular class, and remain blessed. All right. Thank you.